A parabolic mirror, symbol of our modern age of communications. Transmitted to one of the multitude of satellites circling in space, images, sounds and data orbit the Earth at dizzying speeds. Transmitters and receivers are linked by waves all over the Earth and far into uncharted areas of space. With the aid of a satellite, a car driver can find his destination in a strange city. Electromagnetic sensor technology helps him park correctly, and with his mobile phone he can telephone far across the Atlantic from his car. All these things have become part of everyday life. Yet they were only made possible by the visions of individuals, visions which benefit mankind today. Heinrich Hertz, the man who discovered electromagnetic waves. This memorial stands at the center of the campus of Karlsruhe University. In 1825, a far-sighted member of the aristocracy of Baden established Germany's first polytechnical college here. The red sandstone building later became the Friedrichiana Technical College before expanding to become the university of today, a dynamic center of research and technology. Heinrich Hertz was born into an affluent Hamburg family of merchants in 1857. He had a talent for taking new theories and translating them into a practical form, thus making them visible and demonstrable. His teacher and mentor was the famous physicist Hermann von Helmholtz. In 1865, the Scottish physicist James Clerk Maxwell had published his electromagnetic field theory. In the context of a competition, Helmholtz encouraged Hertz to work on Maxwell's theoretical equations and the assertion that light is an electromagnetic wave. In 1885, Heinrich Hertz was offered the chair of physics at Karlsruhe Technical University as successor to the experimental physicist Ferdinand Braun, the later inventor of the cathode ray tube. Hertz took over the auditorium, which today bears his name, and used it as his experimental laboratory. The students were denied admittance until further notice. He needed the total length of the room for his experiments because the equipment he had built, with the inductance coil on the left as the transmitter and the receiver on the right, was only capable of generating radio waves with a wavelength of about 60 centimeters. The sketch of the experimental layout shows rows of benches. At the back of the room, Hertz marked where the reflector, a 2-meter-high zinc plate, was to be set up. The room had to be completely blacked out if the weak light signals at the receiver were to be visible at all. Sometimes it took hours before Hertz and his assistant were able to adjust their eyes to the darkness. The inductor is switched on again. The electromagnetic waves propagate. The waves hit the zinc plate, are reflected, angle of incidence equals angle of reflection, and strike the receiver. The assistant steps into the beam path. The human body absorbs the waves. The consequence, no sparks at the receiver. In 1887 to 1888, Hertz proved the existence of electromagnetic waves and demonstrated their properties by means of this and other experiments. This discovery immortalized Heinrich Hertz. His name is known throughout the world and is even a unit of measurement. The Hertz is a unit of frequency, and 1 Hertz is equal to 1 cycle per second. With his discovery in the Karlsruhe Auditorium, Hertz opened the doors to the age of electronic communications. 6 years later, in 1894, the Italian Guglielmo Marconi and the Russian Alexander Popov started carrying out experiments on the wireless transmission of radio signals. Marconi, who who had meanwhile emigrated to England, succeeded in establishing the first wireless links across the English Channel in 1899 and the North Atlantic in 1901.